Okay, good morning and welcome to IJCAI Day 3 here in Buenos Aires, where we're having a great scientific conference and also a hugely successful social event. I'm very pleased this morning to be able to introduce Manuela Veloso. Manuela is a professor of computer science, the Herb Simon Carnegie Mellon University in Pittsburgh in the United States. Manuela is one of the leading figures in artificial intelligence and robotics, and here today she's going to tell us something about her work. Manuela.
Hi, good morning. So today in this lecture I'm going to give at this conference for a wide variety of AI researchers will be on making intelligent robots a reality. So basically my presentation is going to be about explaining that intelligent robots are the result of research on an integration of capabilities, in the sense that these robots have to have a way to perceive the world. So they have cameras, they have all sorts of different sensors, and basically by looking through those sensors to a scene of the world, they need to be able to extract, for example, position of objects, their own position in a building, and eventually use this perceptual information to connect to what we call the cognition module, in which the robot automatically makes decisions about which action should it take to achieve goals. So you have this perception module, and eventually you have this cognition module that allows the robot to decide what to do, and at the end you have this actuation module that enables the robot to execute the actions that the cognition selected. So in some sense, my presentation of these making these intelligent robots a reality will involve, from a technical point of view, explaining these perception, cognition, and action. But then from the reason why I'm talking also about this is because we do have these type of robots at Carnegie Mellon University called cobots, these collaborative robots, that are the result of the PhD thesis of 3 of my students in particular, and now we'll talk about Joy Deep's thesis, Stephanie Rosenthal's thesis, and Brian Poulton's thesis on having them service people in the actual environment. So they escort visitors to my office. My office is in the end of kind of like a difficult corridor, and so instead of giving directions to the visitors, I just say, okay, don't worry, cobot will meet you at the elevator. And at the elevator, cobot is there, and eventually cobot helps people through this navigation in the building, and cobot just says, follow me. Within these cobot, or these service robots, the last topic I'll mention in my talk is something that we have discovered that I think it's some kind of a breakthrough in this autonomy concept, which is that these robots have limitations. They are not completely good at perceiving scenes, so they miss details. It's a very difficult problem from a technical point of view to have a robot understand a scene. They are not good at understanding all the English we speak to them or all the requests we make. So if I say an elaborate request, the robot might not know anything about, bring me chocolate. What is chocolate? And they also have limitations from an actuation point of view. These robots, for example, are on wheels, so they don't go upstairs. And they actually don't have arms, so they cannot pick up objects. But they do have a basket. So what we tried to introduce was this concept of symbiotic autonomy, in which, as opposed to thinking the robot can do it all by itself, the robots can ask for help when they encounter their limitations. So these are robots that move around at Carnegie Mellon, that they have moved for more than 1,000 kilometers by themselves. And if they are in front of the elevator, they say, could you please press the elevator button for me? Very nicely, people say, sure. They press the elevator button, and then the robot navigates by itself. So for that little chunk of the execution of the task, the robot cannot perform the action of pressing the elevator, but it can ask for help, and the humans around help. For the little chunk of bring me chocolate, and it doesn't understand that chocolate word, the robot actually asks the web, and where is chocolate in general, and we have all these theses of Mehdi Samadi on how do you extract from the web this knowledge. So, and in summary, so what I'll talk about is these intelligent robots being capable of having perception, cognition, and action well integrated, but also realizing that they have many limitations from a technical point of view. And therefore, they engage on this symbiotic autonomy, asking humans, the web, and in fact other robots in the building for help when they encounter their limitations. The result is that they are able to navigate fully autonomously without anybody chasing them or without anybody checking what's happening at Carnegie Mellon already for more than 1,000 kilometers, and in particular that is the major accomplishment of Joy Deeply's vast thesis.
Okay. Thank you, Manuela.
Thank you.
Really great example of how AI and robotics technology is helping society and making possible things that weren't possible before. Next up, I'd like to ask Jesse Thompson from the University of Texas at Austin, who's also working in robotics, who's taking a slightly different slant on things. Jesse.
Hi. So at this conference, I'll be presenting our work on integrating natural language and robotics, particularly interpreting natural language commands to mobile robots through human-robot dialogue. And this is happening because when we want to talk to a robot, we want to be able to talk to it in words, because typing to it is a little bit cumbersome. So when we say something to the robot, if it doesn't understand, it needs to be able to ask exactly where its misunderstanding was. So if I say to the robot, bring me some coffee, it understands perfectly, it can get it. But if I say, bring me some Java, maybe it's never heard this word before, and then it needs to ask, what did you want me to bring? Because it knows most of the command, but not the item. And then if we say coffee, when we rephrase, the robot can retroactively think, okay, so I saw coffee, I saw Java, these must mean the same thing. And next time it hears the command, it'll be able to understand it. This is a simple example, but it can also do something more complicated, like if I say, I'm thirsty or I'm parched. The robot has no idea how to interpret this because it's not a command. But if it eventually gets the user to say, please bring me some water, the robot can then retroactively think, okay, if someone says parched, this means water and bring it to me, and then I'm indicates that it should come back to this person, something like this. So we implemented this system, and I'll present that we tested it on both our real robot and in a large simulated experiment. And what we found was using this versus not adapting to these kinds of questions, just asking, finding out the right answer, and then executing the action, versus actually learning from what the user said back to the robot. Users, over the course of just maybe 30 dialogues with the robot, so 30 people interacting naturally on the floor of our building, found that they found the robot less frustrating and that it understood them more. And additionally, the dialogues took much less time. So we went from something like 18 user utterances, that is the users having to say, yes, no, coffee, no, start over, that 18 times to 4 times for something like bring me coffee or to take coffee to this other person. So in conclusion, we're doing this work at the University of Texas at Austin, and like Manuela, we have Segway bots, nautical bots that run around our building, and they concurrently take delivery and navigation tasks similarly, and we're looking into expanding those tasks soon.
Okay, thank you, Jesse. Okay, third and finally, I'd like to ask Francesca Rossi. Francesca Rossi is Professor of Computer Science at the University of Padua in Italy. She's also currently President of the International Joint Conference on AI, the conference that we're currently at. But what Francesca is going to tell us about is a recent funding initiative by the Future of Life Institute for making AI more robust and beneficial. Francesca.
So I would like to talk about this recent funding initiative by the Future of Life Institute. So the Future of Life Institute is an institute that has been funded by some people, mostly with the energy and enthusiasm of Max Tegmark. He's professor of physics at MIT. And I currently am in the scientific advisory board of this institute, and it has many initiatives. And recently, it organized a very interesting meeting in January 2015, where the emphasis was to put together people from artificial intelligence, but also people from other disciplines like philosophy, psychology, economy, law, and others, to discuss together what the future impact of AI on society is going to be, and how to direct this impact into trends that could be only beneficial to society. And out of that meeting came an open letter that was published on the web, where basically there was a the suggestion of a very constructive approach to these issues, to understand and discuss and work also from the point of view of research on the impact and the ethical issues involved on the impact of AI on society. And out of that meeting also came another interesting result, which was a very generous donation of Elon Musk to the Institute with the purpose of funding research projects that were following the ideas of this open letter and the accompanying document to the letter, so to build intelligent systems that are also beneficial to society. Of course, nobody wants to build intelligent systems that are not beneficial to society, but here the emphasis was on research projects, facilitating research projects where people were especially interested in understanding not just how to make systems more intelligent to achieve their goals better and faster, but also the emphasis was on this beneficial effect and impact on society, also considering the ethical issues involved. And since then, out of this funding, the Future of Life Institute received more than 300 applications, and recently there was announced the winners. I mean, those that applications that were accepted. There were 37 applications altogether, or projects of different topics, from different people from different disciplines, but mostly multidisciplinary. So there are mostly projects of people involving people from AI, but also from these other disciplines that I mentioned before that were present at this meeting and discussed together these issues. So the projects will be starting in the fall and will last for up to 3 years, and we really hope that this will start a new trend in AI in really focusing not just on making systems more intelligent, but also beneficial to society.
Okay, thank you, Francesca. So that draws to a conclusion our third press conference for IJCAI 2015. Hope you'll join us tomorrow morning at 8 AM for the fourth and final press conference. Thank you.